Good advice. Okay. Um, all right. Name that movie. Anyone?
Flight of the
Flight of the
Navigator.
Navigator.
All right. Mark one. Good job. Okay. So this is the overview. We're going to talk about what OpenMP is. That's going to be most of the talk. I'm going to talk about a module I created called OpenMP Environment. And then I'm going to talk about some inline C stuff since OpenMP is for compiled languages. And then there's another module that I created at the behest of somebody on the PDL IRC channel that thought it would be a good idea, and I agree. So that was a good experience, and plan on continuing developing both of these modules. And then I would talk about an issue. There's some um, I don't know what the word is. It's not exactly so OpenMP environment doesn't work like you would want with like an inline C program, and we'll talk about that and exactly what I mean by that. All right, so OpenMP is a high-level declarative pragma-based annotation of C, C++, or Fortran that will allow the developer to let the compiler or allow the compiler to basically thread the code automatically. So the typical use case is somebody has, and this is a common case in high performance computing. Say there's some old crusty Fortran code, Fortran 77 or Fortran 90, or somebody has some C code or even some basic C++ code. They can go in and basically decorate the loops. I say HPC because it's typically heavily loop based matrix computations, and it's straightforward to basically pick the loops out and say I want to thread this loop, and then here's some attributes that I want to give to the automated threading. So that's basically what OpenMP is. It necessarily involves the compiler, and it is an industry standard that's been developed for quite a number of years, and all the major compilers support it. My examples are going to be with GCC, and they have their GOMP library that is distributed with GCC now and has been for quite some time. I think since one of the 4 dot versions. So what I'm going to do next is I'm going to recall a presentation that I created in 2011. So before I worked for cPanel, I worked at the University of Houston. And before I worked at University of Houston, I worked for LSU doing high performance computing. And when I was there, I got to play with all kinds of fun stuff. One of the technologies on the big supercomputers, one of them is MPI, which is message passing interface, which it's neat, but I never really got as interested in that as I did OpenMP. But OpenMP specifically is meant for shared memory, large shared memory environments, and then threading code in an easy way. So this is the group I work for at University of Houston was called HPC Tools. It's no longer there, but it was a fun experience. And this is a very long presentation, and I'm just gonna try and skip to the main points. But like I said, understanding this is important. And stop me at any time if you have any questions. So we're talking about right now programming in a compiled language like C, C++, or Fortran on a machine that has many CPUs in it that are connected over shared memory. So think of a modern multi-core machine. This is a diagram of one such machine. It's got 4 CPUs, and it's got each CPU has. I know things have drastically changed these days, but back in 2011, this is pretty standard. The CPU would have the closest memory to it, which is very fast but small cache, the level 1 cache, and that would be per CPU, let's say. And then on the socket, maybe there were 2 CPUs per socket. There was a level 2 cache, and that was shared between the two. And then all of the CPUs and their pairs communicated over main memory. So to the programmer at a high level, the memory was consistent all the way down to the CPU, but the using things like cache coherency protocols, and the CPUs maintained this illusion, but in reality, it took advantage of things like time, like temporal locality, they call it, which is computations that happen very quickly to very close in time to one another, and in terms of memory, spatial locality. So say that you were operating over a matrix, and you could do like stride operations over many elements at a time. It was the CPU and the cache coherency protocols were able to efficiently manage the I guess maximize the cache hits and minimize the cache misses. But that's the environment that we're working in. So this is going to be like bare metal. We're not talking about VMs or anything like that. This is you're working on a bare metal machine where all the memory is connected, and you've got multiple CPUs.
You were silent for about 10 seconds there.
Oh, um, well, I guess the whole point of this is basically the architecture model we're working with. It's just a shared memory machine. It's not a VM. There's multiple CPUs, multiple layers of cache. But for the program and for the programmer, it looks like just a coherent, set of memory that's shared among all CPUs. That's probably the big point there. Okay, so multi-processes on a system. So I know I talk a lot about like, threaded things, and I like to say Perl doesn't have real threads, and people get upset because they don't understand what I'm talking about in a lot of cases. But I think it's just an issue of terminology. When I talk about a thread, I'm talking about a well, here is we're all familiar with processes. When you issue a command in a command line, or the operating system runs a program, typically it's a single process. It's a sequential line of execution, and people often, and I do this myself, fork processes and take so um, they can take advantage of the multiprocessor systems. But ultimately, each process has its own memory, and it doesn't share memory with other processes. So when I talk about threading, I'm going to be talking about a single process that can spawn multiple lines of execution that can execute on the different CPUs, but it shares memory. So it's a single logical process, but it's threaded, and it can share memory, and that offers a lot of benefits. So what the MPI model I mentioned, message passing interface, it's just that um, it's basically taking the communicating sequential processes approach. I forget who created that concept. Maybe Tony Hoare. I forget. In any case, it's a very fundamental concept in computer science when you're talking about concurrency. So MPI assumes that each process is not doesn't have shared memory, but it provides basically a library for each process to communicate amongst themselves. And MPI in particular, and I think it's implemented. It used to be MPitch. I don't remember what MPitch, the CH in MPitch stands for, but it's OpenMPI now, and it's a maintained library. It supports different languages, and it supports different uh, like network topologies like InfiniBand and regular Ethernet. But in any case, the capabilities that MPI give you they start with the assumption that you have these sequential processes that you want to be able to communicate with others, and it gives you these neat functions to basically communicate like arrays and different data structures, and to gather information and coordinate information among these communicating sequential processes. OpenMP takes the other approach where there is a single process and the communication is done implicitly over shared memory. So we have one process, we have multiple threads. Each thread can run on its own CPU, but each thread has access to the same memory. And communication, typically, when I say it's implicit, I mean that communication is done through, say, the value of a specific variable. Um, say a the algorithm you've implemented is operating over an array. Well, you can logically separate that, given a thread ID, that this thread can operate over one chunk of the the array and assign it that way. But you can also do coordinating things. You can have all the threads updating a single value. Of course, that introduces a race condition, and OpenMP provides for atomic operations for that reason. But in any case, the whole computing model here is that all threads can see all of the memory, and it's up to the developer or the programmer to ensure that the memory is updated in a safe way, that there aren't race conditions and that sort of thing. And OpenMP also, so it's not like a general concurrency, framework. It implements a fork and join model. And I know fork means a certain thing in Unix and in Perl. Join means something else. But in this case, when I say fork, and that's the terminology that's used in OpenMP land, I mean that a single process hits a fork point and then it spawns some number of threads. And each one of those threads gets assigned to a CPU. If there's not, if there's more threads than CPUs available, then the operating system manages that through its process management. So a lot of this model leans heavily on the operating system, which is for a lot of things is where it should be. But this is an example of where a single process forks in and does stuff. So it forks into 4 threads, and each thread gets put on one of the CPUs. It does stuff, and then there's a point where the threads come back together and are ended, and then the main process continues on as a single line of execution. And this is a very common, or I should say, this is a very useful model when it comes to doing things like for example in HPC when you're operating over matrices. Okay, so this is kind of like a stepwise example, so, of what it means to share memory. So we have the original example. There's 4 threads operating in shared memory, and thread 0, say it declares within the shared memory space, it declares an integer. We'll just call it A, and then say that thread writes to A, and then now you can have thread 1 read from it safely. You can have thread 2 read from it safely, and then thread 3, 0 index threads, of course, reading safely. Okay, and that avoids, if you have one thread writing to a single variable and then the other threads reading from it, that's a form of communication. So that's what I mean by implicit communication. Is thread 0 doesn't have any idea who the readers are going to be. It just writes to this space in memory, and then the other 3 threads will take advantage of it. So there's no explicit communication there. Now in MPI, thread 0 would literally send the value of A as a message to the other processes, and that's a good example of the difference. Okay, let's see. All right, so OpenMP, as I said, is an industry standard. It's run by this group called the OpenMP Architecture Review Board. And on the next bullet point under that is just a sample of the different companies and organizations that are involved in it. Basically, it's the de facto, high level shared memory. If you want to call it a domain specific language, you can, but that is the main interface that is provided to, I guess, the high performance computing audience at large. There's nothing really sophisticated or unusual about it. It covers many of the common cases, and that was the main selling point, I think, and the main reason why all of these compiler the companies that provide the compilers and use the technology were signed on to it. But you can see Texas Instruments is in there. They use it for their signal processing chips. So they've not just TI, but a lot of these companies have moved from just basic shared memory paradigm to actually offloading to accelerators and using other exotic types of hardware. But I'm not going to get into that because I don't know anything about it. So it comes with, there's a user level API. So, okay, so there's OpenMP is made up of several things. There's the directives, the declarative statements that you can put in the source code. Those are called the directives or the pragmas. That describes the threading that you want the compiler to perform over the code. It comes with a user level API. So those are things that you can put in the code that you can set, different environmental variables. You can change the number of threads. You can you can set, it's basically a bunch of setters and getters to manipulate the actual runtime environment. So there's the piece that translates um, the OpenMP, the source code with the OpenMP declarations into a compiled program. And then there's a runtime aspect that gets invoked that actually manages the invocation of the threads and then the servicing of these different API calls. Um, let's see what else. Yeah, I mentioned Fortran, C, and C++, and it does have a pretty, even today it's very popular. And I'm actually surprised that Perl hasn't had any kind of interfaces to it, but I guess it was time, and my interest was there, so I did it. This is, but I'll get to that later. This is an example of a C program that has been, I guess, threaded with OpenMP. If you can look at it, the OpenMP parts, or at least the declarations or the pragmas, are the green lines, and they are hidden behind comments. So whether it's C, C++, or Fortran, the OpenMP pragmas are hidden behind actual code comments. And the reason for that is the code is supposed to be able to compile serially. If the compiler either doesn't support OpenMP, or it's not told to look for OpenMP. And as far as I know, most compilers have it off by default. But this is just a simple C program. Um, the so the second include line is necessary for the runtime calls. Okay, an example of a runtime call is the OMP get num threads, and that's just a way to query and ask, okay, how many threads do I have? And you can do different things with that. The next line, that green line, that's a declaration. You're saying that this is the beginning of a parallel program, and then it allows you to determine, to specify what variables are going to be shared among all threads, what variables you want to be private among each thread, and then there's a lot of other things that you can do, but in any case, the starting section is this pragma OMP parallel. And then within the block, that's the body of the thread. So you can, it's kind of like the semantics here is kind of like, a fork and thread or fork and Perl, where once you call it, everything after that, you can assume is being run by each thread. Let's see. The next, that pragma OMP barrier, that is a synchronization point for all threads. So that says, okay, I want all threads to operate independently, and then once they hit this line, this barrier, execution of the threads, execution of all the threads must halt until all threads are there, and then they may proceed. So that's what that's for. That's an example of a synchronization point.
Brett, could you go back to that for a second? I'm sorry.
Yes.
Okay. On the line above the green pragma OMP parallel, you say get number of threads. Is that what is currently running, or what's available to thread your little program, or what is that value?
That's the number. And actually, looking at this now, based on my working with the examples that I have for this talk, that's actually in the wrong place. So, but in any case, that's assigning to this numt integer the number of threads that are operating in this environment.
All right. So if there's a mistake, maybe, okay, so the next line you say OMP parallel private and then numt. So you're passing in a number. Is that telling it the number of threads it wants, for this execution?
No, that's saying so the above line. So, okay, when I say it's a mistake, I'm saying that I'm pretty sure this worked when I created this presentation, but I also wasn't using GCC. When I now using GCC, the it I was not that was not doing what I expected it to do. But what I expect this to do is that it assigns the number of threads that you're intending to run to this numt, and then in that the parallel pragma right below it, it's saying that you want that variable shared available to all of the threads.
So they know how many threads are running, is what you're saying.
Exactly. And this is
Well-
kind of a trivial example because each thread could run that call itself if it wanted to. But
So how many threads does it spawn or fork?
well, that we're going to talk. We're going to be talking about
I'm
that
ahead of you. Is that what's going on?
just a little bit.
All right.
But
Go ahead.
that's a good. I'm glad you're thinking in that direction because that's one of the main environmental variables and one of the main things that you can set. By default, it's 4. The number is 4, at least with GCC.
Gotcha.
The default is 4. So, but yeah, please let me know. I'm glad you asked. This slide is just a timeline of when OpenMP was created, and now again, I created this presentation in 2011. I think now they're up to, I think they have a draft for 5.0 now, but this is about as far as they've gotten up to this point. Okay. Oh, I was even making nice references back then. Team Wolf. So this was more for the HPC and audience that I was given a talk for. I was basically trying to drive home the point that OpenMP and MPI are not the same thing. Because a lot of times, I used to do training for both when I was at LSU and at UH. And a lot of times, it took people some time to understand because they had been programming in MPI, and it took them some time to understand, okay, OpenMP is totally different. It is not better than MPI. It's just another option. And a lot of times people can use MPI and OpenMP together, it's called hybrid parallel programming, which is also an interesting thing. But in any case, that's what that is. But you can't compare the two. They're not competing for anybody's mind share. They're appropriate for different situations. OpenMP is supposed to be portable. Well, that's kind of got an asterisk by it these days because compilers have the interface itself, like the pragmas and the runtime environment and the runtime API and the environmental variables. Those are all standard. Things that are not standard, we all are used to dealing with standards. A lot of things that are controversial are just not defined. So basically, it's up to whoever implements the thing. Well, compiler writers, and a lot of times standards are only implemented by one or two things. Well, with OpenMP, it's implemented by a lot of things. It's implemented by a lot of compilers. And each compiler tends to have its own flag and make its own assumptions about things. So it's portable, yes, but you need to make sure that it works with your compiler. If you're going to be, you want to be using it on Portland Group, Intel, GCC, and all of this stuff. You need to make sure it works for all of the compilers you claim it does. And you can't just write it for one compiler and expect it to work for others. Another note I have here is that it's good for incrementally updating serialized code. A lot of, at least initial users of OpenMP were working with old code bases, usually Fortran 77 or Fortran 90, and they wanted to get a performance boost because they were heavily matrix operations or other things that could just be, loops that could be broken up and easily threaded. So OpenMP allowed somebody to take existing code and just start inserting these directives and just start playing around and see what kind of performance improvement they got. So it was really, and it still is beneficial for that. But as we all know, with shared memory programming, you start running into things like race conditions, and unless you're careful, if you have even a moderately complex algorithm, you're gonna your code's gonna be doing things that you didn't intend, because maybe you're not thinking that implicitly about what's happening. So it quickly can get complicated, I guess is what I'm saying. Yes, and OpenMP is fun. I do encourage y'all to play with it through GCC. I think a lot of stuff could be done with it. It's kind of neat. Let's see. I already talked about that. All right, here's a sample, at least in 2011, all of the different compilers that implemented it and what version specification they supported. I don't know if this list is bigger or smaller these days in terms of what compilers are actually available out there, but most compilers have, the ones that do support OpenMP are pretty good about supporting at least the standard version 4.0 and above. What is the difference between that and 3.0? I don't know, but clearly I'm not covering anything above 3.0 in this because it did not exist at the time. But there's a lot of options out there that you can use, but most people are going to be using GCC, and that's been turning out to be the greatest avenue of distribution for OpenMP. And a lot of things do use OpenMP. Like, for example, ImageMagick uses OpenMP to speed up some of its routines. And I know this because, not because I looked at the source code, but because there's a flag when you're building it to disable OpenMP, and I am aware of that flag. So let's see. Oh, so when I was working at University of Houston, they had their own compiler, and I didn't do any actual compiler work. I mostly wrote like OpenMP benchmarks and did training and worked with the graduate students who were doing actual research and compiler work. At the time, these were options. The research compilers listed here were what was out there. So OpenUH was the name of the compiler that the group at University of Houston had, and that actually was a fork of, I think it was called Open64, and I forget the company that they open sourced it, and then the group at University of Houston took it and implemented OpenMP, one of the earlier specifications. But Nanos was a thing. I don't really remember that. It was a thing. MPC was a thing. What's not listed here, and it's because it was just starting back then, was LLVM, which is what Clang is based off of. And so nowadays, so GCC tends to be, more of a production ready implementation of OpenMP versus LLVM, which is used primarily as a research framework for a lot of the OpenMP research that's being done right now. Because what tends to happen with OpenMP is somebody, and there's a lot of academia and corporate R&D involved. Somebody will propose an idea, or say an academic institution will propose an idea, or a commercial entity will say, hey, we will fund your great idea if you do this. So there's some collaboration between industry and academia. But what tends to happen is, in order for something to get into the specification, it needs to be proven, and it needs to be a generally accepted idea. So, for example, the support that OpenMP compilers have in the current specifications for accelerators, like offloading to GPUs and other exotic processors, say that TI has, it first started off as basically a group that was looking into the feasibility of even offloading, and then that kind of led into a subgroup that was exploring the whole idea of tasking rather than threading. So it kicked off many years of research and work, and even trying to figure out, is this a good idea? And then once people just determine, okay, here's some things that we can narrow down and work on, then there's a whole phase of somebody has to implement a proof of concept, and they have to flesh it out that way. So it's not, it's very much a working group, and working standards body where ideas have to be proven, and then somebody will come out from left field and say, well, this is all nice and well, but you're violating, this memory consistency model, and that I invented in 1975. And then then there's these super high level conversations about memory consistency, cache coherency, and all of this other stuff. So anyway, my whole point is there's a lot of activity around it, and LLVM tends to be the target for a lot of that, prototyping and R&D stuff. All right, now this is probably what y'all were waiting for. This is using IBM's compiler suite, which I haven't used in a long time, since this is the last time probably I used it. But this just shows what it looks like to compile a program that has OpenMP directives in it, and just an example using compilers that support it. And here we're using two non-GCC compilers. XLC is the now XLC_R indicates that I guess that it supports threads, or that it supports reentrance with functions. But in any case, that's when you're invoking, and it may still be the case today, when you're invoking an OpenMP, the compilation of an OpenMP program using the IBM suite, and at C, you would use XLC_R. And then you see the flags there. There's -Q S and P equals OMP. And then you're familiar with the test.c-o test.x. Well, and then Julian, this goes to your question. If you want to tell it how many threads to use, and you haven't specified it in the program, you would set this environmental variable.
I
And
see
this
that now.
Yeah. Well, no, I mean, I'm glad you asked that, because that's kind of where I was. That's my main environmental variable, I guess, that I'm going to be manipulating later. So in any case, you can see that the example below, it's the compiler, and it's UHCC whatever. Now instead of, you see for the IBM it was -QSMP equals OMP. For UHCC it's -MP. But for whatever differences there are between these two compilers, and compiling them, you execute it the same way, which is nice. And that's kind of where the standard focus is on the execution side. It doesn't tell the compiler what flags to use. It doesn't tell the compiler how to do the source translation. It doesn't tell the compiler how to, what threading library you have to use, even though most of them use pthreads. And I've got an example of how things actually work under the hood when compiling a program. Okay, I'm gonna skip this. Let's see. Okay, back then, this is a good summary of the different constructs and directives that you had. To actually, declare a parallel region, the start of a parallel region where the threads actually do the forking. It's the parallel region. So you saw the OMP parallel. Well, that is the bare minimum you need is OMP parallel, and then you can define a block underneath that, and then that block will be executed by however many number of threads. There's work sharing constructs. There's ways to single out specific threads. I think later on I have an example using master that basically just says here's a section within the threaded environment where only they call it master, but it's really the thread with ID 0. That according to the standard, that's the logical continuation of the parent thread that did the forking in the first place. There's mutual exclusion, atomicity, synchronization, some synchronization constructs there. Now the asynchronous tasking, so that's exactly what you think it is. It's kind of a different model. Well, it is a different model than threading, where it's more of the, we're familiar today these days with futures and async await and things like that. That's what this means, is it kind of creates a bundle of work and just shoves it off somewhere. It could be on one of the CPUs, that's just executed immediately. It could be sent to a GPU or some other kind of accelerator. In any case, I don't have any examples of that. But below that is data environment. I think I showed an example of a shared variable, which was the number of threads. There's the private, which that declares private variables within each thread scope. Thread private, I don't remember what that was, but it's different. It's slightly different than private. Oh, wait. I think that private may be, it has to do with the initialization, like the initial value. It's still private memory to the thread, but and then reduction. So reduction probably shouldn't be in data environment. Well, it kind of is, and I've gotten a code example that uses reduction. I shamelessly stole an OpenMP program that computes pi. So, and that necessarily uses a reduction. By a reduction is like if you were to sum things over, a number of threads, or pick some kind, use some kind of aggregation like min or max. If you wanted to pick like the maximum value computed among all threads, that sort of thing, it just provides you some conveniences for that.
Is there a significance between the colors on that slide?
Let's
Like in
see.
that last section, some were blue and some were green.
No, no, that's weird. Nope, that was just an oversight on my part. Good question though, because I do that sometimes. I even use I used some different casing too. So, but no, thanks for asking. Okay. Oh, so now all these kind of examples, this is kind of interesting. All these examples I use OpenUH compiler. So this isn't how GCC implements it. This is how the OpenUH compiler was implementing it. And I'm not going to drill down and show you the names of each thing, but when the compiler converts the high level, say C code or Fortran code that's been decorated with the OpenMP into a, it starts compiling it. The first step is it basically inserts a bunch of these high level, they call it scaffolding, that basically facilitates the insertion of the threading into the provided source code. And the root of this tree here, it's something fork, I don't know. In any case, that it gets inserted wherever that OMP parallel declaration is, and then that does has the call tree that you see there, or a similar call tree. So it can get pretty hairy, the compilation. All right. This is important for later, because this is basically what the kind of stuff that the OpenMP environment module deals with. OMP num threads is the most common environmental variable, and of course that is a way to tell the runtime environment of the OpenMP program how many threads you want to create whenever you hit a parallel region. OMP schedule has to do with, so if you have a for loop, it basically, the scheduling affects how the iterations are chunked or executed. You can either have it, and in which order basically the loop gets unrolled. So I'm not going to, I almost tried to explain it without an example. I'm not going to do that because I will confuse everybody, including myself. Anyway, you can see how, so OMP thread limit, that is a maximum number of threads that you can fork. I've never really seen that used in practice, but I assume maybe if you were using like nested threads, which is a thing, then you might want to use that. OMP max active levels also refers to nesting. OMP nested may turn it off or turn it on. I've never actually played with nested threading, but if you have like 32 CPUs, you could theoretically do some iterative forking and fork within forks and that sort of thing. I've never done it, and I've never seen it really done, but it is definitely possible. These are the execution environment routines. We got the setter getter for num threads. Set get, I forget what dynamic is. I think it has to do with the scheduling of the loop execution. I get like the loop unrolling. Locking routines. Oh, so it comes with locks. So even like there's the barriers that you can use, but you also have runtime interfaces for actual locks. And then there's nested locks, which allow some recursion to happen using locks. Um, the timing routines. Oh, that's for doing benchmarking. OMP get W time and W tick. And in fact, the example that I have later on has that, the one that is computing pi. I already covered this. Yeah, go ahead. Yes. Yeah. Oh, yeah. No, absolutely. You're right. Um, yeah, that's good. That's good to know, especially since we've kind of talked a little bit about that regarding that other module. Cool. I appreciate that. Um, let's see. Okay, so this section, I think it starts with it starts with the implementation of how the compiler actually facilitates OpenMP. I mentioned before the compiler translates the initial code, and if you tell it to be aware of the OpenMP declarations, then it'll do some source to source translating. Usually that's how it's handled anyway. It basically just converts it. Okay, this is probably a interesting slide for y'all because it talks about at a high level how the OpenUH compiler does things. And since this was an early implementation of OpenMP to begin with, a lot of compilers do follow this model. I don't know if GCC does, but I would not be surprised if it, I would be surprised if it didn't follow some sort of thing. But so the way to read this is, let me refresh my memory of this. So, okay, so the up, can y'all see my mouse? Okay, this block
Yes,
right.
Brett, I can see it.
Cool, thank you. Okay, so the parse into very high whirl. Whirl is within the OpenUH compiler, or I guess the Open64 compiler, was like this high level intermediate code representation. And you'll, if you're familiar at all with LLVM, and I'm not terribly familiar with it, I do know basically what it does and why it's used by compiler researchers, but it basically, you're just going to be iteratively converting the high level source code into lower and lower levels of source code that can then be compiled as, say, not like just normal C or normal Fortran or normal C++. So with Perl, let me think. I definitely think that is true in the sense that it takes the initial source code and it creates a data structure out of it. And then that data structure, and that's probably what the whirl is some sort of a tree. And then the rest of the process will iteratively work on nodes of that tree. And then probably necessarily create subtrees. And then it's been a while. It may even then reconstruct using that tree, so the low level C code or Fortran. So yes, I mean, I think that's probably true. Let me see. Well, yeah. So I guess that's basically that's what this. So I'm glad you asked that question, George, because this refreshes my memory. So basically, with the pools, it's a stepwise process that it it takes the source code, puts it into a data structure that the compiler can then manipulate, and then find opportunities to shove in, low level runtime calls that can just be directly compiled or whatnot, and then ultimately ending up with your actual compiled code. I think I have. Yes. Okay. This probably says everything in one slide. So on the left-hand side, you've got a basic parallel program using OpenMP, and it's super simple. It's just saying hello from whatever the thread ID is. Okay. On the right-hand side, this is actually what gets compiled. So it takes these directives, the one directive, the pragma OMP parallel, that has the attributes. Um, it sets default none. I forget what that does, but private. Each like before, each thread has its own. It knows its own ID using the same variable name. But then on the right hand side, that's what gets compiled. So there's a source translation from the left hand side to the right hand side, and then the right hand side is just pure C with some internal runtime calls. So you can see how how I guess raw or low level it can get, and how they take advantage of an internal API to convert it. But to go from the left hand side to the right hand side takes that whole process that we just showed here. And in that case, I don't know if you've ever used. I think is it BC, which is the Perl compiler. You can have it compile, quote unquote, compile Perl code into C code. But if you open up the C code, you'll see it's heavily structured with Perl runtime calls, and that's very, if we want to use an analogy with Perl, it's very similar to that. Yeah, there you go. Here's another example, and I even have a comment. Nobody wants to code like this. so it goes from the OpenMP declarations to this. I mean, some people might want to code like this, but probably it's more interesting to write programs that create this kind of stuff from the former. Okay. Okay, so this double underscore OMPC fork, that's the internal, I guess, fork. I wonder if I have any examples now. So the last thing I want to note about how things are converted from OpenMP to this is, so where is it? I don't know where it is, but anyway, the OMPC fork, underneath that, like at least for OpenUH, it uses pthreads to implement the actual forking. I think IBM uses its own threading library, but in general, most lean on pthreads pretty heavily. This is an example of a C program. It just says hello. Now you'll notice the output's probably more important here. There's no ordering. There's no guaranteed ordering. So it depends on, it just depends on how the operating system schedules the work on each CPU. If you ran this 4 times, you might get 4 different orderings of the hello. But each one is running on its own CPU. It's not. It is happening simultaneously, or at least independently, I should say. Okay, so here's a Fortran 90 example. You can see that at least the directives themselves are basically the same. I mean, with C and C++, there's the blocks defined with the braces, and then with Fortran 90 and Fortran 77, it's just going to use the begin and the end sort of paradigm, where rather than using the braces or the blocks, it just uses statements. So you'll also notice between the two, C and C++ use the pound pragma, and then I think pound pragma is like a standard thing, And then after that, you would specify OMP. So I guess the idea is at some point there would be other, other things taking advantage of this pragma capability of the compiler. But and I don't know if it's a C or C++ standard, but I wouldn't be surprised if it was.
Yeah. I mean, this is
It's a
definitely
C
built
standard.
into C. I
Is
mean, you
it?
can do things like inline, assembler, all sorts of things you can do.
Oh,
with
neat.
Pragma.
Okay.
Yeah.
Very good. Okay. Well, that's good to know. I kind of assumed that it was like a standardized thing, but at the same time, I'd never seen it, or at least never noticed any other examples. So, Yep. Oh, do they? I need to take a look at that. That's funny.
Okay.
So,
Unless Fortran has changed much, that's because there's a character in column 1. That's a comment.
that is true. You know what? I haven't tested this theory, but I would not be surprised if it required exclamation point $sign.
Well,
For
that's how it
for
makes it a macro, but as far as Fortran is concerned, that's a comment. So
yes.
that's how we overlap those two.
We're dating ourselves, Wade.
Yeah, I know. I can't help it.
No, I'm glad y'all are, because that's good info.
You're glad you got the old people in here? Great. Nice to know.
Well, you make me feel young, so that's why I hang out here. All right. Okay, this is just, I guess, emphasizing the parallel sections, but these do the same thing. You see the difference between C and C++ actually embedding, but you'll notice like the parallel private and then shared, those are identical. So you're declaring the same stuff, just using different language features to do it. This is a trace of the execution we just saw. So one thing I wanted to point out is I have this if TID is equal to 0, and on the Fortran program, I have the same thing. I could have used, so only the thread ID with ID 0, which is the master thread, is going to actually print that last line, which says whatever number of threads say hi. I could have used a master section, like it would just be like OMP master, and then have a block define whether it was in C or C++. But that's basically what that construct does, to single out the master thread. Okay, we'll move on. But this is what happens. So there basically everybody says hello. Everybody checks to see if their thread ID 0, so it's not super efficient. Only one is, and that one gets to say hello, or gets to say the last line, I should say. But then afterwards, on the right-hand side, you see the join. And then so after the parallel barrier, all the threads are dead. The master process continues on as a single process. Probably not. This is just some information on these more specific examples and information. I'm gonna be sure to send this link out, because I went to go find this and I couldn't find the actual PDF, and then I went and found it on SlideShare, and I knew that it had like a couple of hundred views, but it's got like a ton of views now. So I think it's pretty helpful. It's definitely one of the more comprehensive, if not the most comprehensive, presentation on OpenMP out there. So I'm definitely going to send the link out to y'all, and I think that it probably would be helpful if you're interested in it. But again, it's an old standard. It's the like standard 3.0. They're talking about 5 now. So, but all this information should still be valid. It's just not the full picture anymore. Oh, this is a reduction. I don't know why these are underlined. I guess SlideShare does that kind of stuff. That might be why it's colored different too, because I don't think in the PDF it's actually like this, or maybe it is. So I wanted to point out the reduction. So what this is doing here, and again I have a C and Fortran example. It's declaring T as the number of threads. So this time I'm doing it within each thread. Each thread is making its own call to get the like to ask, okay, how many threads are operating totally? And then it's participating in this reduction operation using this variable I. And whatever, so we're not explicitly saying that I is shared. We're not saying that it's private. We're just telling the compiler that, hey, we're going to be using this variable I as a placeholder to reduce a value that is being contributed to by all of the threads. And in this example, it looks like we have to tell it that it's going to be an addition reduction. So clearly the compiler is going to be doing some special bookkeeping with this particular variable so that each thread can write safely to some portion of memory. And then once all of the threads have written to it, or at some point at least prior to the end of the parallel section, it's going to need to necessarily combine all of those values using the operation specified. So we could definitely emulate this using an array where each thread contributes a value to a index that is whatever its thread number is. And then after we get out of the loop, just add everything together. But using this reduction operation, it makes everything nice and tidy. And then once you're outside of the reduction or the parallel section, I is available to the main process, and it is the value that you're gonna expect. So, and so in a Pi program that I stole, it uses reduction to compute that. Okay, that's the trace. Okay, it's just that's just showing what I explained to y'all. Okay, so it can do bitwise reductions. That's cool. I mentioned min max before. It's more of an aggregation, but it's still needing to necessarily look at the value contributed by all of the threads and then pick the high or the low.
Min max is still a reduction.
Yeah, I agree.
It's not aggregation at all, actually. Aggregation is just putting things together in a collection, whereas reduction is replacing two values with one value.
Very good. Okay, I'll take your definition because I think that's right. Okay. Let's see if there's anything. This is just more like examples of things and ways to explain the execution. More specific. This no wait optional for the for, that's some. So with when the for loop is being parallelized, you can have it, I guess, by default, where there's some waiting that occurs at the end of the block before. Oh, that's what it is. So if you have a for loop, within a parallel section, if all of the threads are going to be participating in the iterations, okay, let's say that there's some distribution of iterations among threads. If there come, and you can do it in chunks, so like you can say like each thread gets 5 iterations. If there comes a time, well, there will come a time when all the iterations are finished, yet threads will continue to come back for more work. If there's no more work, then this no wait pragma says just proceed. By default, all the threads are going to wait until all of the work is done, and then they are all going to proceed together. But if you use that no wait, it just says if there's no more work for you, then just move on. That's what that is. So you hopefully you're getting the idea of how it's taking this fork join thread model and then giving you these tools and these different things to tweak to coordinate and make the actual execution as efficient as possible. Yeah, that's a good example. Oh, these are different schedule types for the loop. I'm not going to really go over that because I'd have to figure it out and then explain it, which you guys are more than capable of reading. But maybe your appetite has been whet enough to start playing around with this yourselves. Oh, these are critical sections. So the OMP section that defines critical sections. That means that each section will be executed by one and only one thread. So in this example here, you've got the overall section that just says within this, I've got other sections. We've got other sections defined, and then it allows you to basically distribute work, and I guess in a strided way or some sort of you know allocate. So you have 6 threads. 3 of those threads are going to land there first. On each one of those, they're going to do the work, and then all the work's done, and then it'll just continue. So that's another way to control the work distribution among the threads. Yes, that is a very good example. And I think you may even be able to put that within a for loop. So you can then, I guess, iterate over them.
I'm not sure. The nomenclature may be part of the problem, but I know I've used critical sections in Windows threading program, Pragma or whatever you call
Well,
it.
I shouldn't have said critical section. There is a critical section, and there is what you're talking about is a critical section. This isn't a critical section. These are just
Okay.
sections. This is
Right,
what
yeah,
George
because
said.
I use critical sections in Windows threading for making atomic operations.
That's what that's for. And in fact, I just misspoke, but I'm glad you brought that up because I don't want to confuse anybody or make
And
you think you understand incorrectly. I more than likely I'm just misspeaking, and that was true in this case. What's that? Did you say something?
I was about to say, yeah, and the term, although Windows programming was an example, I would consider critical section to be a generic term that would apply to any OS.
Yeah, it's a generic operating system concept. If that's what you mean, because that's the context I've heard it in. Okay, this is just going over some more specific things. Oh, I talk about. Oh, I'm not going to go over this. This is task stuff, but page am I on? Oh, let's see. Okay, we're almost done here. Da-da-da. Anything? Oh, here's some critical sections. So okay, there's a difference, Julian. So critical section is what you think it is. All threads execute it. The section that I showed before, the section construct, it gets executed by the first thread that lands on it. And only once.
Cool.
Let's see here. Okay, and so here I have an example of pipelining. I guess that's what it looks like to me. Where you've got critical sections, all threads are going to be participating in the critical section, but it causes a cascading effect, and there's going to be some necessary linearization of the threading, but they will at some point during, I guess it looks like, well, only the T2, there are threads executing over all 3 sections. Certainly, if you had more sections and fewer threads, you would be keeping those sections busy. So I guess that is pipelining. So yeah, so that's something another thing you can do to tweak out some efficiency in this fork join model. Let's see. Locks. Just kind of, what is that? It's just talking about different. I guess they call them sentinels. So, okay. So Wade, back to what you were talking about. So in OpenMP, at least back in 2011, these were your options. It would be $! C $, which I think C was kind of a convention for comments in Fortran, and then $. But that's
asterisk was another convention that we used for comments, but it was actually
Yeah.
just something in the first column.
was exclamation point a convention?
It was any non-space character.
Yeah, I mean,
Right,
it was,
in the
you had
first
a
column.
program.
it was, yeah, whatever was in the first column indicates that it is a comment, whereas you could put just
So-
about any character.
Yeah.
So if you really
gotcha.
wanted to screw somebody up, you unindent their Fortran code,
Uh-huh.
and nothing works.
Right.
It's a
Chopping off
horrible
of
thing.
the first letter of your function.
Well, they're all now
Oh, it would be a
comments, 'cause
comment. It would
you've
just be a
got-
comment. Yeah.
Yes, exactly. Not that I ever did such a thing.
Never. Back when versioning was tarballs.
That was pre-tarball.
Retardable. Great. Oh, that's funny. Okay, I just have some. Oh, here's an interesting example that I actually did myself way back then. It's just a computation of an integration of a continuous function just using area. Um, Probably should have taken that code rather than somebody else's, but anyway. So I guess that's a practical example or a more interesting example or a real example of something you can do. Some more stuff. Um, and I think that's it, at least for this. So any questions about OpenMP? That is all just to set up some examples of the work the couple of modules I've been playing with.
Oh, that's interesting stuff. I like it.
Oh, good. I think, well, I think the biggest barrier is just lack of, I mean, ignorance, like just not knowing the people who actually can or will get into that code, just either being aware of OpenMP or being interested in giving it a shot. But I think there's given the reason for OpenMP and its iterative nature, um, I think that there's got to be some places within Perl core that you could introduce it that way. And Redis is sort of the same way. It's at least back, a few years ago when I looked at it, Redis is typically, and I'm talking about just it running, on a single machine. Redis is typically a single process. But there are portions and things that it can do using threads. So it's sort of threaded. They say it's threaded when it can be or when they need it to be. But in general, it's single. It's a single process, and a lot of that has to do with the atomic guarantees that they have to have around some of their the operations. But in any case, that kind of reminds me of what you're suggesting, which I do think that there's probably opportunities, but you ask those people something like, hey, can you do this? No, it's like, it's, can't be done. So I agree. Yeah, I agree. That's definitely something to look into. I've been getting a little curious about the Perl implementation. I don't know how, if I will ever pursue it, but if I ever did like dive into it, I probably would be looking at that with that in mind. But then again, I have no idea what I would find in there or if I would even understand it. Apparently, it's like crazy, but I can't speak for it myself. But I think I guess my answer for you is that there's probably places it could be used, and I agree. It allows a pretty conservative application of I think threading. So okay, so Oh, wow. It took a long time. So, all right, 20 minutes. I could probably cover what I need to cover here. But stop me if you have any questions, as always. Okay. Now I can say, well, now I can say, or you guys can understand what I mean here when I'm talking about OpenMP environment. It's literally just a Perl module for manipulating the environment. So if you want to run an OpenMP program, it gives you a Perl interface to updating env, and that's pretty much it. Um, now, why would you want to use it? Well, if you're somebody who has written an OpenMP program and you want to manage the execution of that, and it's the different controls you have, you could build that. You could build the sensitivity to the environment into your program, and then manipulate those environmental variables to have your program do what you want it to do. In most cases, it's the number of threads. Okay. Um, but in a lot of cases, um, where was I going with that? In most cases, it's the number of threads. Um, and in most cases, or actually in all cases, that is managed using a shell script. So it's kind of, it's not a surprise to hear that people manage OpenMP environmental variables using shell scripts. And on HPC systems that have uh, that where somebody has to submit a job. So the way that HPC systems typically work, at least the large systems, like at the universities and other places, when you log in, you're logging into like an interactive node or the head node, and that's where you would compile stuff. But the actual compute node that's the bulk of the computer itself, the cluster, I should say. You can't access those directly. You have to submit your job to a job scheduler. Common one, I think the most common one these days is called Slurm. I don't know if anybody's played with that, but if you've got like a large compute cluster and you want to manage multiple users who are wanting to run their massively parallel programs, then you'd put Slurm between them and the compute nodes, and they would have to. And it allows like you can assign them a certain number of, they call them service units, and do accounting of who's using what and that sort of thing. But in any case, when you have a batch environment like that, um, what you're submitting is basically a shell script with some, say you want to assign, you have an allocation of a certain number of service units associated with with your account. You want to define that account within that shell script using a special variable that the batch system knows about. In any case, the assumption is that you submit the job, it lands on a compute node or multiple compute nodes, and then it gets executed. Well, a lot of times, I probably should have gotten a couple of examples, but you can look at like University of Texas, TACC. They have a lot of examples of batch jobs that you can submit. They're just shell scripts. But when you execute OpenMP programs, it doesn't have to be a shell script. It just needs to be an executable, really. But when you execute it, you're typically setting the number of threads that you want in the environment, and then the executable runs and then spawns that number of threads. So there's launching OpenMP jobs on these large compute clusters. There's benchmarking. Benchmarking is a very common thing, and in fact, I'll show you. Hopefully, I'll get to it. Within the OpenMP environment, I actually have in the example directory, I copied down. NASA has, I think they call it NPB. I forget what it stands for. So like maybe numerical parallel benchmark or something like that. But it implements multiple algorithms using multiple parallelization approaches. One's like MPI, another one's OpenMP. I took the OpenMP stuff and have an example of running that benchmark specifically while controlling the environment using this module. And then, okay, so that's for people who primarily use OpenMP. Like I could see somebody who's, a lot of people run benchmarks with OpenMP, like people who are involved in the standards board or research work. It's like benchmark, benchmark, benchmark. I ran a ton of benchmarks when I was at UH. And I got really good at writing these shell scripts. I would definitely use this over shell scripts if I had to do that today. So that's for people who primarily use OpenMP. For people who primarily use Perl, it's interesting to consider not just executing like binaries within a Perl script that are able to be that are threaded, and then you can control them using the environmental variables. But I've got a couple of examples that show using OpenMP within like say an inline C program. Basically, it's creating inline C. I'll show you. It's just an easy way to create a foreign function interface to a compiled shared library that's accessible within the Perl program. So it's like avoiding writing excess basically. But since it's just C, or I guess it could be just Fortran or C++, within the implementation of the compiled language implementation of whatever you're doing, you could use OpenMP, and that kind of goes back to what George was suggesting, which um, was, can you use OpenMP somewhere in Perl core? Well, you can definitely. I can tell you right now, we can be writing XS modules right now that use OpenMP heavily, and then that would be giving you basically threaded subroutines that are getting called within the single process of Perl.
Well, that's exciting if you can get it in there, because Perl is notorious for not being thread friendly. And
Yes.
if they could make it somehow, that would just be so cool. And like grep or map, as George pointed, would be a simple low hanging fruit.
Yeah, and
Well, not necessarily, considering that the code inside there could be doing anything and not be thread safe. Like the Perl code would have to be annotated, or they would have to recognize that this stuff is actually safe. Like if it does.
yes, I mean whoever's implementing would would have to know. I mean, it wouldn't just, they would have to be able to confirm their assumption. Yeah, and since OpenMP it's available, it's certainly available in GCC, and I mean, not 100% of Perl installations are compiled with GCC, but pretty close to that, I would say are. So yeah, I mean, OpenMP is available for most XS modules, or we'll see some inline C examples here in a second. So yeah, I mean, I'm glad you guys are excited about it. I think it would be a cool thing to take a look at. Okay, alien modules. I didn't know what alien modules were until I did this. So I got on pound PDL, on the IRC, or irc.perl.org, and one of the main guy on there, who his name is Mohawk or something like that. He's the release manager for PDL. He was like interested in getting, exploring some OpenMP support within PDL, and there's some other PDL specific things he wanted me to look at, which I have kind of looked at, and I may explore further at some point. But in any case, his first suggestion was, hey, why don't you create an alien module? And I was like, I don't know what an alien module is or what it's for. So he pointed out a few to me, and eventually I realized that alien modules are basically helper modules for using inline C, and by providing the different compiler flags basically for a specific library. So alien modules encapsulate library specific compiler flags, so that it's no longer part of your, like if you're using it doing inline C, as long as the alien module you were using with whatever libraries you were including supported the compiler or the environment you're running in, you no longer have to juggle all the different crazy flags, which is nice. and I'll show some examples. I mentioned FFL, the foreign function interface. The guy who does like Platypus, and he does a ton of alien modules. He's super nice and super helpful. He's always been willing, and all the people on that are either in Pound PDL or Pound Native is another one where they talk about the FFI stuff and alien modules. They're all super helpful. So if anybody is ever interested in doing that, jumping in and asking questions there is no sweat. Trust me, I've asked them some really dumb questions and they've been pretty patient with me.
What is the SPVM again?
Okay, I'll get there.
Oh, sorry, I jumped ahead.
That's fine.
I'm sorry about that.
No apologies. Okay, so next line, PDL parallel CPU is a I just wanted to mention this, but it is like a pthreads kind of interface for PDL. Well, I should say it's a way to it's like an interface for using pthreads. It's not like OpenMP. I haven't played with it, but excuse me, I believe it works with what's called PDLPP. It may even be, I think you can use it directly without the PDLPP. But PDLPP is, and you should look it up because I'm going to do a terrible job of describing this, and I don't have time to cover it. But it's a high level way to describe some methods or functions that will in turn get compiled. So PDL has so much like stuff and support for managing arrays and compiling programs and using foreign function link. I have FFL. It's supposed to be FFI. PDL has a lot of stuff. It can use FFIs. It can use pthreads directly for some things. But in any case, that is another avenue to explore for threading, is all I'm trying to say. Now, SPVM, Static Perl Virtual Machine, is it is a framework. It's kind of like, to me, I haven't played with it. I've chatted with the guy. I think, George, you mentioned that you've chatted with the guy, or at least know the guy somehow, who created this. It looks really cool. It's basically a framework for providing access to whether it's compiled languages or different computational environments, or data like accelerator environments, GPUs, OpenCL. There's a way to include like OpenMP programs. It's for utilizing these lower level libraries that are meant for taking advantage of the computing environment, the architecture that you're on. So anyway, that's probably a terrible explanation, but I do encourage you to look at all of these things. Well, FFI, let me fix this because it's bothering me. FFI is a general term, but I believe it is also a namespace, a proper namespace in CPAN. In any case. All right. I have some examples to show. All right. Let me turn on some lights here. It's getting dark. Okay. Can y'all see me, or what do y'all see right now?
I see another Flight of the Navigator thing.
Yeah, it says thank you.
Oh, that's all you see. Okie dokie. Well, I wonder if I can share my terminal.
I mean, I'm not sure if that's you inserted into it because it doesn't look like a 10-year-old boy or whatever.
That's not me. That's the alien guy. That's the alien guy from the Discovery Channel or History Channel. Let me make it bigger.
I do have a question. So on the previous slide where you have a list of a few projects related to Perl parallelization, since you're interested in this subject matter, have you looked at RPerl at all?
Yes, I haven't played with it, but I have looked at it. insofar as I was able to determine that it was basically, I mean, our Perl stands, I think, for restricted Perl, right? And it's able, it's restricted. It was my impression. It's restricted in such a way that it can be uh, optimized, drastically optimized. Um, I don't know if it has anything to do with compiling into like say object code, but it may. But
Basically, the project basically takes Perl code. It takes a Perl code limited to a subset and with annotations, and it basically translates it into equivalent C++ code, which
okay.
is then compiled as C++. But one of the reasons I bring it up is that one of the already implemented features is automatic parallelization.
Oh, cool. Okay. I know that there's a it's Will, right? Will the Chill Brazil, whatever.
Yeah,
I forget
that's his thing.
Yeah, I know he's got a like a full book out um that that I downloaded the PDF and I started flipping through it a little bit on the computer, but it looked really interesting. But that's what you're telling me is kind of like more than what I understood, but that sounds, I mean, I definitely want to take a look at it. It sounds pretty interesting.
Yeah, it's very much a work in progress. Like unfortunately, unfortunately, it's not really in the state where you can take Perl code which is not annotated, and like you can't just take the same code and run it on the normal Perl compiler, the normal Perl runtime, or run it through his system to make it faster. It's like, even if ostensibly that would work, you still have to include a module which is specific to him.
Yeah,
Maybe
I see.
for the annotations.
Right.
So I find that that project has promise, and in fact, I give him a little money with Patreon each month to support it because of the potential. But I know I've tried, but it's far from a state where I personally can use it at this
Yeah.
time.
Well, I mean, I know, like, I know he's done work with. He was involved in that Perl 11 stuff, and I think worked with Rainy. Rainy might even be involved in this. Like that whole, for me, I think all that's really interesting. I think it's a shame that it had to be like a separate effort like that. I think that's cool. I do want to check it out, but I think I'm starting to remember like some of the reasons for our Perl. And wasn't it related to, do they use like more VM at all? Or is that,
I don't
am I
know.
making it up?
It's basically all about performance. Basically, the
Okay.
idea is that the, no matter how much you otherwise optimize it, basically other Perl efforts, the actual performance is quite slow among programming languages. Whereas our Perl is all about performance. So it's like, if you have, and for all practical purposes, it is a fork of Perl.
Yeah.
Um, the if you write something, and if you write something basically to what it understands, it can basically turn the Perl code into something whose performance is comparable to C++.
Right. Right.
So basically, it's all about performance.
Right. Cool. Yeah, I'll definitely check that out.
And that's like orders of magnitude difference, like could be
Oh
100
yeah.
times as fast.
Yeah, definitely.
Whereas other performance things for Perl would make it maybe twice as fast. So
Yeah.
I think there's various efforts in place. I consider Ovid's thing, what is it, that new object system, the
Core.
Corina or something. I consider that to be something serious, which I think if it is done well, or I guess probably more like version 2 that includes type annotations, because version 1 won't do that. Once there's like something standard like that, that's basically in the Perl core just for annotating types, or I mean something that's better than what's already there, then you're in a better position where these projects could more coincide. Like you could have something which is like real normal Perl, but it's also possible to make it fast.
Yeah, that'd be awesome. I mean, I'd love to be able to just program in Perl and just, compile down to native speeds and have efficient binaries. Cool.
Unfortunately, there seems to be there's unfortunately there's big social issues basically between Will and a lot of other people, such that I think for the most part, the people maintaining the normal Perl are basically ignoring our Perl. And Will's trying to get them to pay attention to it, and like
they ignore a lot of stuff
together.
to their detriment. Yeah, well, it's probably good company to be in, honestly. I don't know. Yeah, yeah, exactly. Yeah, or at least like some, like better than what you had, right?
The thing is, though, I find now, even though I support our Perl and whatever in concept, I find that as I perceive it, I find that Will Braswell's whole philosophy seems to be rife with self-contradictions, because on one hand, Will is very gung-ho for basically Perl is the greatest thing ever, and he will only ever use Perl and whatever. And it wants Perl to be number one, but at the same time, the way he advocates using it with all these restrictions and various things like that, it's so severe that for all practical purposes, what he's advocating using is a language which is very different than Perl.
Right.
So
that was the impression I got with when Sawyer X was introducing that guacamole thing. Like, when I forgot what he called it, standard Perl. As it kind of struck me in the same way, where yeah,
like I can understand like avoiding certain aspects of Perl that are more problematic, but it's like Will's philosophy is so severe that he's basically saying only use about 10% of the language and ignore, and the other 90% is bad. That's more what it looks like. And in that case, it's like you say you like Perl, but on the other hand, you simultaneously saying you don't like Perl.
yeah, I can see that. Hey, let me right. Let me if you guys don't mind, I'm just going to show you some quick examples, and then we can have whatever conversation you want, because I personally find it interesting. I just want to wrap up real quick. And I can do it. So when I was talking, this is a shell script that just executes a binary, and you can see that I don't know if this would help. Line number 7 here is actually setting the environmental variable OMP num threads, and then in the for loop, I'm just iterating over some number of threads, and I'm gonna execute that real quick. And this is the shell script. Takes a second. The one thread takes a second. Well, 9 seconds probably. 8 seconds and 8.7 seconds. It'll speed up though. You'll see, and you'll see the speed up too. You'll see, okay, 2 threads took, 4.6 seconds. 4 threads took 2.3 seconds. So the speed up's pretty good. This machine has This is actually, it's got 16 cores. This is not my machine. This is the SDF large shared memory machine, which is really not that large.
Though there
memory.
does seem to be a fatal flaw because it's producing different values of pi for each version.
Yeah, I mean, like I said, I grabbed this off of the internet, but off of GitHub. But this is the implement. Is this the implementation? Oh no, wait. This is the original implementation where
Actually, the fact it's using doubles is probably the main part of the problem.
yeah.
Well, I mean, the fact is,
If it was doing it exactly to a certain precision, then the values should line up more.
yeah, I was about to say the thing that I always said at TI was, it's an approximation. I can give you a different wrong number.
Yeah,
Okay,
they are
so
approximations, but it's like we're saying this is pi to 20 digits or something. And then if we're saying it's to 20 digits, it should be the same 20 digits.
yeah, I agree. So look, let me point this out. This is the original code, and here it's actually iterating over a number of threads. Okay, so it's not even using that environmental variable OMP num threads. It's iterating over from 1 to max threads, which is defined up in line 4, which is 8. And then this is an example. Line 24 there is an example of a runtime, the runtime API method or call that sets the number of threads. The actual example that I'm running is this one, which I actually the reason I modified it a bit, but the main reason I deleted all the spaces because I was putting it on a slide, but then I decided not to because I have it here. But what it's doing rather than uh, iterating over a number of threads from 1 to 8 or whatever, it's just running it once for whatever OMP num threads is set to. And here, line 16 is where it gets the number of threads that is being specified from OMP num threads. And that is how this script is working or affecting the program, I should say. Now, OpenMP environment, it's doing the exact same thing. It's just doing it in Perl. And it's just doing a for each over 1 through 16. Now, this is just an example of it setting, like I said, this module, it's really just manipulating ENV. That is all it's doing. It just has interfaces for setting and getting whatever the environment, whatever the OpenMP specific environmental variable is. So it also has some like other things, handy things, but yeah, y'all can go take a look at the Perl doc if you're interested to see. But this is the essential use case right here. I will execute this and you'll see the same exact thing. Hold on. Hold on. Where is it? Oh, what? Anyway, all right, here we go. Oh, forget you. Okay, so it's doing the same exact thing. It's just affecting the environmental variable, and you're going to see the same sort of output, same sort of time scales, same different wrong numbers. Hey, at least it is the same wrong numbers. Awesome. Okay, so that's the essence of the OpenMP environment. Now, I need to move this. The zoom things keeps dropping down. All right. So the next thing I want to show is the inline C example. This zoom thing is really annoying me. Oh, I know why people are chatting. Ah, okay. I wonder if there's a way I can not be notified. Oh well. All right, so I'm looking for my inline. I'm going to show you an example of using inline and OpenMP. Okay. Okay. I already have them open. Okay. So this is the first example, and basically what I have here is it's using inline. So in this case, it's inline C, and then I'm passing in what inline C does is it takes some C code and it basically allows you to not have to do excess stuff for you. I don't know what the internals exactly do, but it allows you to call whatever function you've defined within your foreign language through a Perl binding call. And in this case, I just called it pi. And here I'm iterating. Now I'm not using that OpenMP environment module, and but I'll show you an example of using it, and I'll kind of talk about the sticky situation or the problem that exists. And it's really not a problem. It's the nature of it. So let me run this real quick. Um, I think I already had it compiled. So the code is literally running. It's not compiling, it's running. So it's running on one thread. Looks like we're getting the same numbers before, which is cool. So here it's iterating over one number of threads 1 through 16. So it's running the driver is the Perl process is within the Perl process. It's calling this interface to this compiled library. That the library itself, it's the same computation of pi that we had just done, so that it creates the function pi. It's accessible to us in the runtime, the Perl runtime. Now the variable, instead of using OMP num threads, I'm passing in the number of threads that I wanted to use. This seems to be the most flexible approach that I've found so far. It doesn't, so the OMP num threads environmental variable doesn't work as I wanted it to work, but I understand why it does not work as I want it. Okay,
So
so here's
I can see why you're getting different results for different threads. It's because of the way the reduction works. You're going to have more and more operations, which means rounding errors are going to get more and more severe each step.
okay, Leah, there you go. But and that's good. That's actually good. Good to point out. Good time to point out. Also, it's a reduction. We talked about a reduction in before going over the OpenMP stuff. But here we go. It's a summation reduction. Let's see. So line 35. So I think it's pretty obvious how the C code is defined. In the data section, and it's just being imported um, using inline. This flag, CC flags X, is that -F OpenMP. That's the compiler flag that you would pass if you were compiling an OpenMP program in GCC. And then for the linker flags, it's necessary to include um, set the linker, the additional linker flags. And what we're doing here, somebody on the PDL IRC channel actually helped me figure this out. But I'm basically just appending to the linker flags. Now this config : config, that hash is all the information that Perl was configured with when it was built. So we're doing basically is just taking whatever linker flags were included when Perl was built and then adding the -F OpenMP. And again, it's necessary to add them in both places if you're using inline C. So that's example 1 with inline. Let's see. This is example 2. What is different here? Oh yeah, okay. I'm using the alien module. So let me close this. close the one I wanted. I'll get it. There you go. Okay, this is the original one using inline C. You'll see that I'm specifying the compiler flag and the linker flag. With alien OpenMP, you can see rather than specifying the two sets of flags that I need, I'm just specifying the keyword with and then pointing it to alien OpenMP. Okay, and what that, like as I mentioned before, the alien set of modules is meant for encapsulating things like compiler flags that you're going to need when either using a library or some other compiler related thing. OpenMP is, as I mentioned, it's not only is it a library, usually distributed as a library with in GCC it's gomp dot or libgomp I should say, but it's also a compiler flag, so it's an additional flag. So the alien set of modules is definitely appropriate for this. I'm going to open up the Perl doc because it's not really. Where do I want to go? So this is just to show you that the alien module provides the C flags and then the LD, the linker flags. And then it also, let's see. Now, in order to implement the with, the stuff that with the inline keyword with supports, then you need to implement an inline. It's like a implicit method that gets called within the alien module by the inline module. It looks for whatever your module you provide and then : inline. That inline just provides a hash of the data that we would be providing anyway in that example. So in our first example. So rather than having these two lines here, 9 and 10, this with just tells inline to call this the inline method of the alien OpenMP module, and it gets that data. So it's just a nice way to encapsulate things. That's all this was to show. Now, the final example I have is why after all of this am I not using OpenMP environment and inline? Well, the reason for that is because and I'll tell you a quick progression of why I misunderstood this. When I first created OpenMP environment, I was doing it from the perspective of I'm running basically I'm recreating a shell script. All I need to do is be able to manipulate my environment, the environmental variables that the OpenMP runtime can understand. So I implemented it. It worked as expected. When I was running these external binaries, no problem. Same thing as the shell script, no problem. Well, then I got the bright idea. Well, I'm gonna create an inline method because I want to be able to create a functional interface to a threaded thing that I can call in the Perl runtime, and then be able to use OpenMP environment to adjust it. Not because I wanted to use environmental variables, but because I wanted to use the interface that I created. And I found it wasn't working. So then I realized, well, I asked a lot of stupid questions to some really smart people, and they were patient and finally figured out where the disconnect was. When it's working, so when you run a binary executable, it's launching once, it's running, and then it's ending. And typically when we're setting the environment, it gets executed under that environmental context, and then the executable finishes and the execution context is over. If we set the environmental variable again, that's a new context. Well, if we're writing a shell script, we're running one shell script, even though the execution context of the binary is different each time for each iteration of the, however many threads you want. When you're executing something with when you're using inline, it compiles um, it compiles down to a shared library, and then it does its excess magic to give you the runtime Perl interface to the method you've just compiled. Well, just like in the original use case where you're loading a binary once, you're executing it, and then it's ending, the same thing is happening with the foreign function interface. The library in this case replaces the binary. But the library is getting loaded once, and the way that OpenMP, the runtime works is it inspects the environment once. So I can set an initial value for something like OMP num threads when when that library first gets loaded. And it's like frozen or fixed in place. It's not frozen or fixed in place because of anything to do with Perl. It has to do with the fact that, at least with libgomp, and I haven't gone and looked at the OpenMP standard to determine if this is actually a defined behavior or not, but the environment is only inspected once whenever the executable that's being run within this OpenMP runtime context is started. So, you know, so I guess what I would like to do is I want to be able to run something that I've compiled using inline, like, well, something that I've compiled in inline, say use like in this way, this example, but without having to pass in the number of threads, not because I don't want that sort of semantic control over the number of threads, but because I was kind of hoping to be able to use it like OpenMP is used, which is there's that whole idiom of setting the environmental variable to determine the number of threads. But if we can't get it, we can't get it. It's not a big deal. One thing I did want to show, last thing I want to show is, so this example, this final example shows where I mentioned that OpenMP environment works with an inlined method, just like it works with a binary, calling an external binary, but it fixes it in place. The difference is here, you're not like using the system command to fork off an external call each time. You're using a library call within the same process to call it, except the initialization of the library doesn't happen again. So you're not actually able to change the number of threads. And I'll show this example real quick. And then I'll be done. And then we can do whatever. Let's see. All right. You see the output there. I'm iterating from I want 1 thread, 2 threads, 4 threads, 8 threads, 16 threads. But because when I initialized it, you'll see within this begin statement, I set the number of threads environmentally to 8. That is what the library uses every time the method is invoked. And even though I know I'm passing in the number of threads here, in the rush, I couldn't figure out how to create a void context call. So I'm just passing in an integer that I'm not using. So that's the only reason that's there. But but in any case, what I would like to happen is, you'll see on this line 52, J is getting set to the number of threads. Well, the number of threads was set in the begin block through the OMP num threads environment when the library that was compiled with inline was compiled and loaded. And then from then on, unless I call a runtime command in this compiled code to set the number of threads, it's going to be fixed at 8. So that is working exactly as it should, but at the same time, it's a little bit unexpected. Well, it's not unexpected. that's not where I was coming from OpenMP, which necessarily has these different semantics using the environmental variables. So that's all I've got. I'm sorry I kept y'all so long.
So I'm curious, does the data section in Perl have a means to actually inject the environment so that it would do more or less what you want?
That's kind of where my mind went, which is, and I haven't looked at this. I created OpenMP Environment a few weeks ago, and I hadn't really looked at it since, but I do want to, and I intend to probably tonight because I found some things I need to fix in it. But in any case, when I was looking at it and I discovered this, one of my thoughts was, is there a way to kind of inject? So to take a step back, I did enough research and I got enough help from the folks on PDL to find where libgomp is actually reading the library, like not a library, the environment. So it's actually it's during an initialization phase. It's actually just like doing a get env over the environmental variables it cares about. So I started playing around with what would it look like if, to make that call during the runtime rather than just do like OMP getting them threads. What if I wanted to reinitialize the environment each time? What would that look like? And I know it's possible. I didn't come up with a working example, but one of my thoughts was to inject that somehow. But that seemed kind of gross, but at the same time, I got diverted to other things. So
To be fair, it sounds like that could be computed more or less at compile time. So if you were making a module with this, you could have it as part of your build script and not really worry about it.
oh, I see. I see. That's a good thought.
Well, could that int xxx, shouldn't that be the number of threads you want? And can't you say OMP set num threads to be
Well,
xxx?
yes, but I guess that's what I was saying is the way that OpenMP is used doesn't it assumes that you can modify the environmental variable. So like I guess to put it another way, yes, you can do that, and that's actually what the second example does. But I want to be able to um, what I want to be able to do, I guess, is this. I didn't complete this example. Yeah, I definitely didn't complete this example. I want to be able to do this,
Right. Okay.
and then let me just.
Well, I,
That's not
being
going to work.
a little pedantic on my own, passing in that XXX, you could call the op num set num threads. That seems perfectly perfect for me. But
It
if you really are hell bent on using an environment, you can change the environment inside the C program.
Right, and that's what I was contemplating, and I think that George was suggesting being able to do that, I guess dynamically during the
Well, I mean,
compilation
you can
phase.
say call. There's a call called set env or something like that, where you can do something analogous to $env in Perl. I haven't used it in 172 years, but I know it's there. So you can do it, but like that is so inefficient compared to passing in int xxx there.
Right.
That's just me.
No, no, no. No, I totally recognize that that's the right way to do it is to pass number of threads in. I was trying to align it with how
Oh, okay. So
OpenMP
you
is
just had your mind set on this other approach. Okay.
right, and it probably isn't the right approach. I think it's clearly not the right approach. I just you know it's an example of one of those things where OpenMP it does things kind of like kind of bends over backwards for some things, and my mind had gotten a little warped, but I still kind of want to do it, so we'll see.
Okay.
But that's a perfectly reasonable example, and yeah, why wouldn't that be sufficient? I don't know. I think it should be. So um well, look, I apologize for being late, and I appreciate everybody who stayed on. Hopefully you guys found this was interesting, and I'm gonna bundle everything up and get it to y'all.
I love the inline C approach to this because that gets around the lack and poor threading that exists in Perl, and you can put it right there. Now, if you could actually make XX calls, I mean, you talked about it briefly,
Oh, well,
but
let me show you. I can do that.
using XS, it would just be cool.
So look, Julian, is this what you mean? So here, oh wait, here's a better. This is probably the ideal example. Like it uses alien OpenMP. It does not use OpenMP environment. But it uses alien OpenMP to encapsulate the compile flags, and then the function interface that gets created. I'm passing in the number of threads I want, and then it uses OMP set. Where is it? Right
Yeah,
here.
right there. I don't know what line is, but I can see it.
Yeah.
Yeah, you got it marked.
So this like this seems like the normal, or the what would be considered the best approach.
Oh yeah, I agree.
And I just wanted to show you that we did have that example. So
Right. Yeah. So, but what I veered off into the ditch, and so in this ditch, I'm looking at like how can we get around the lack of threading in Perl, and using this inline C thing looks perfect. And then, like I said, you talked about doing XS. I think somewhere's in your presentation here, but you didn't touch on it very far.
no, and I
But
don't know. I know what XS is. I've written an XS module with lots of hand holding, but I can tell you, and I think again, this is what George was I think alluding to, is there's some opportunity there's certainly things you can do within the Perl runtime that would
right.
like some really targeted
Yeah,
uh
you could do your matrix manipulations right here in this inline C.
yeah,
So
absolutely. Or even yeah, you could definitely you could build. So one thing that would be cool, I don't know what it would look like, but one thing that would be cool would be a set of data structures or tied. I remember I talked to Rainey about over email, like over like a couple of years ago, because I've always been interested in OpenMP and Perl. I've always been really annoyed about the threading problem. So I was like asking him what he thought we could be done. Is it possible? And he suggested possibly creating a tie interface. So that's if I think it would be really awesome to have a set. Now I know tie is not super efficient, yeah, but the interface, the concept itself is, I think, is more in line with what I would envision, which is a set of tied data structures that are tied to threaded operations. And
right.
I'm
So
not sure what that would look like necessarily compared to traditional Perl data structures, but it might provide some options.
Well, certainly hash search is highly pipelinable, and that would be a very straightforward thing to tie, I imagine.
yeah,
Yeah.
looking for that low hanging fruit would be ideal.
Yeah, definitely. I agree. Well, it's something, I want to do a lot of things, but I do eventually get to them. And this threaded stuff is kind of getting near the top of my bucket list. So maybe I'll start playing around with it. And the I think the important thing is to just start playing around with it and then get feedback, and then maybe somebody will be like, this is terrible. Let me show you how to do it, and then just do it the right way.
Yeah, what you could do is, if you're serious about this, do this type of work like you're saying, and then do some Perl blogs about it. Get some feedback through the Perl blogs.
Yeah, yeah.
And it's a slow approach, granted, but that's probably the best way to approach it, is because then everybody has eyes on that are interested. So
Yeah, I totally agree. And the other thing that occurs to me is there's also some other avenues. There's some really interesting approaches in PDL. Man, there's some stuff in PDL that was written in the late '90s that it just seems like it's modern. It's modern stuff that we should be like, that should be part of Perl. I don't know. There's some really interesting stuff in PDL, and it's shocking to me that it was written so long ago, or at least some of these parts of it. But one of them is that the PDL PP, which Now, this wasn't my idea. This is a suggestion by the guy who suggested the alien module was, what would an OpenMP capable interface to generating these PDL functions in a declarative way or in a high level way look like if they were to be, basically auto generate OpenMP? Like, is there a way to describe, a small function or, functional kernel of some kind with some OpenMP like semantics so that then that can then be generated with the OpenMP declarations and then, just lean on the compiler to do the rest of the work. So lots of interesting stuff there.
Okay, well,
regarding this whole thing about having the multi-threaded and PDL and whatever more built into Perl and being proper, I should point out that back when Raku was basically the next version of Perl, these were all early concerns that it dealt with. And so if you look at Raku, it basically has all this automatic multi-threading and PDL stuff baked in very fundamentally. So
Oh yeah, but it's not Perl.
no, but it was intended to.
Well, you know what I mean.
It's not Perl now, but it was originally intended to be. So in that sense, it's kind of like we did try to put it into Perl. It's
Yeah,
just,
no,
that's
I get it. Yeah, I didn't. I was kind of referencing the Perl binary thing. It's important to have one, but it's probably very late for that conversation. But anyway, I don't want to cut anything off. I'm done. I'm happy to stay on for however long and discuss, but I've got nothing. No additional content.
yeah, we've been going for over 2 hours, guys. I appreciate everybody's attendance. If you need or have questions, hit Brett offline. And Randall, I'm glad that you came tonight. You're always welcome to join us.